Now, some of these topics are typically covered pretty well in a precalculus course, and some are typically, or some are frequently left out or glossed over. And let me just give you an idea of the way I see this. Analytic geometry in the plane, usually people learn a distance formula, a midpoint formula. They might understand that that's related to the Pythagorean theorem, but they quickly forget it because the formula is usually given on a formula sheet on the test, and they just get a very poor idea of this. When it can be understood more easily and far more deeply in terms of a simple picture in the application of the Pythagorean theorem, or in the case of a midpoint, a couple of similar triangles. Okay, well, that aside, I think analytic geometry in the plane is not well covered, but the rudimentary part does get covered. Conic sections, parametric equations, polar coordinates, very frequently either left out or done in the most superficial manner. Kind of ironically, students don't understand this classification of functions, don't understand functions as families or entities, functions and function families as entities, but they can do pretty well with sums, products, quotients, composites, and they can use expressions related to these functions to solve equations. They're usually pretty good at solving equations. As far as putting expressions and equations into useful form, that's not so much, but that's a pretty difficult thing to do, to understand what a useful form is and then to put an expression into that form. But I think we should be able to do more with that. Constructing graphs, unfortunately, I believe 90% of students that come out of pre-calculus classes think you construct graphs by punching them into a calculator and looking at the picture, and thereby gain no deep understanding of these functions, and maybe that's one of the reasons they don't understand this classification very well. Graphs are constructed by fundamental basic functions, these most basic forms of these functions, and generally by shifting and stretching transformations. And this is always covered in pre-calculus, but students very seldom come out knowing what they should. So a lot of times that just doesn't get done, and this again, the pervasive misuse of calculators throughout the curriculum. I'm opinionating here, and I apologize for that. I can't help it. Rates of change, that's hit or miss. Sometimes it's covered pretty well. Sometimes it's a formula that people use for a while and forget and never really understand. Again, understanding that is not a trivial thing. It's so important if you're going into calculus. Triangle trigonometry and trigonometric identities, as I see it, are usually done pretty well. Students come out being able to solve triangles, right triangles, apply the law of sines, law of cosines, apply the basic trigonometric identities. Vectors, sort of hit or miss, but a whole lot of miss, because that comes late in the course and everybody's always behind, and I'm not throwing stones there because it kind of happens to me too, but I do it anyway. And I'm not sure that's the best idea, but so be it. Matrices, and I'm guilty of this when it gets undertaught, because the rest of the stuff is so much more germane to what follows, but I totally acknowledge the huge importance of linear algebra and the importance of being able to do matrices. Sequences of series, again, something that's an afterthought in most cases, although there are certainly exceptions. I'm just thinking in terms of what I see students come to me with from this institution, from other institutions, and from our secondary schools. Not very well understood. Okay, and the applications and modeling, there's some lip service to this. There's some attempt to do this, and it's a tough sell. It's a hard thing to do with students, but that's kind of iffy. So that's kind of picture of the way I see most pre-calculus courses, just from my experience. And the question then is, what can we do to help remedy some of these deficiencies, at least deficiencies as I perceive them? And I want to proceed to outline how I would go about this, and recommend other people do the same. And if other people don't see these deficiencies, that's wonderful. If they don't exist, if it's my imagination, then I'm kind of wasting my time here. But I'm very happy for the state of mathematics education despite that.